Hello guys, welcome back to PyMOL Studio. In this video, we will perform one single exercise wherein we will try to replicate same molecular representation in PyMOL. The molecule here is the SAM3 riboswitch, wherein the SAM moiety is associated with the riboswitch structure, which is essentially an RNA molecule. So without further ado, let's get into PyMOL. First, we will fetch our macromolecule with the help of fetch command. So type the command in the command pymol in the pymol's command line. Fetch 3E5C. Hit enter. In the molecule viewer window, you can see that our macromolecule has been loaded, which is essentially a SAM3 riboswitch. First, we will strip off all the unwanted atoms from our protein structure. The unwanted atoms means the SR molecules as well as the water molecule. So the green dots are actually the SR molecules which we have to remove. For that, we will select these molecules into a selection name called as ions. So we'll type the command select. We will give the name to the selected atoms collection as ions, comma. We are selecting the atoms with the help of their residue name. Therefore, we will give the selection criteria as res_n, and we will specify the name of the atoms we want to select. In this case, they are SR, and we will hit enter. So as you can see in the molecule viewer window that these pink dots represent the selected atoms. On the right hand side of the window, you can see one extra selection has been formed, which is named as ions, as the name is specified by us. Now that we have selected our SR atoms, we will type the hide command. Hide. The atoms are represented in a sphere representation, so we will write the name of the representation as sphere, comma. We will type the name of the selection, that is ions, and hit enter. You can see that the ions have been removed from our structure. Now we will move on and select the backbone atoms and store them in a separate variable name or the selection name, and we will collect all the bases and store them in a separate selection name. So we will first select all the backbone atoms, which are the atoms present in the sugar phosphate backbones. To do this, write the following command: select. We again provide the selection name as sugar phosphate, which is sp underscore bb, that is backbone, comma. We will type the selection criteria as backbone and hit enter. So as you can see, all the atoms that are present in the sugar phosphate backbones are selected and are stored in the SPBB selection under SPBB selection name. On the right hand side, you can see one more selection has been formed, which is named as the SP underscore BB, which holds our all the atoms present in the sugar phosphate backbone. Now we will make another selection where we will store all the atoms that are present in our nitrogen bases. To do this, we will uh, write the following command: select bases, comma. We are selecting atoms that are not present in the sugar phosphate backbone but are present only in the bases. So we uh, we write a simple not operator to bring atoms that are not present in the backbone. So not backbone and hit enter. So as you can see, atoms that are present in the nitrogen bases are selected. On the right hand side, you can see another selection name has been created, which is named as bases and which contains all the atoms that are present in our nitrogen bases. Now, as we have segregated the atoms that are present in the backbone in SPBB selection, and the atoms present in the nitrogen bases are stored in bases selection. Now we will convert the bases representation from cartoon to sticks. To do this, but before we represent our atoms that are present in the nitrogen bases as sticks, we need to first hide the cartoon representation of this basis. To do this, we will again write the hide command. Hide cartoon, comma, basis, and hit enter. As you can see, all this cartoon representation of bases has been hidden, and what is visible is just the sugar phosphate backbone atoms in the cartoon representation. Now we will make our nitrogen bases visible but in the stick representation. To do this, we will write the following command: show sticks, comma, bases, and hit enter. So as you can see, the nitrogen bases are visible in a stick representation, but they are not actually connected to the sugar phosphate backbone ribbon representation, which gives us the exact representation as I have displayed earlier. Now what remains is coloring of the nucleotides that are present above our ligand structure, below our ligand structure, and to the side of the ligand structure. These three parts of the riboswitch are the famous three domains which enables our RNA molecule to function as a riboswitch. So they needs to be highlighted in three different color so that their significance can be noted down. To do this, we will first select the atoms that are present above, or the nucleotides that are present above our ligand structure, using the following command: select upper, comma, we are selecting the nitrogen bases or the residues on the basis of their residue IDs. Therefore, the selection criteria in this case is residue IDs, which is shortly aliased as res-I, and we will provide the number or the range of bases that we want to select. The upper part of our riboswitch consists of nitrogen bases starting from 8th nucleotide to 38th nucleotide. Therefore, we write the same as 8-38. Hit enter. As you can see, the upper selection has been formed and all the nucleotides that are present above the ligand are selected. In the same way, we will select the nucleotides that are present below the ligand structure. To do this, we will again write the same command, but in this case, we will change the selection name to lower, and we will select nucleotides that are present below the ligand structure. So nucleotides starting from 41 to 47 are located below the ligand structure. So 41-47, and hit enter. As you can see on the right hand side, lower named selection has been formed, which consists of the nitrogen bases or the nucleotides present below the ligand structure. Now what remains are the nucleotides that are present on the right hand side of our ligand structure. To select them, we will write the following command: select side, comma, we will ignore the nucleotides that have been included in the upper as well as in the lower, and we will select the non-selected nucleotides. To do this, we will again write a logical statement not, and in the parenthesis we will provide atoms that are present in upper as well as the lower selection, upper or the lower. This following command line selects atoms that are not present, or it will select nucleotides that are not present in the upper as well as the lower the selections. So this particular command will select nitrogen bases that are present in the upper as that are not present in upper nor in the lower selections. We will hit enter. As you can see on the right hand side and in the molecule viewer window, that all the non-selected atoms that are not previously selected have been selected and highlighted in pink, and all these nitrogen bases are stored in side selection. Now we will provide three different colors with the help of this particular command. Color, we will provide the name of the color we want to give to our upper selection, which is wheat, comma, we want to provide the wheat color to nitrogen bases or the nucleotides that are present above the ligand. So these nucleotides have already been stored in the upper selection. So we will type upper and hit enter. As you can see in the molecular viewer window, the upper nucleotides has been colored in wheat color. We will provide another color to our nitrogen bases or the nucleotides that are present below our ligand structure. To do this, we will again repeat the same command, but in this case we will provide different color to the different selection name to apply to different selection name, which is low. So the color I will write here is light pink, and we are applying this color to the nucleotides that are present below the ligand molecule. Hit enter. As you can see, light pink color has been applied. Finally, we will provide color to the nucleotides that are present next to our ligand. We will repeat the same command, but with a different name applied to nucleotides that are present in the side selection. So olive and side. Hit enter. As you can see, the three domains have been colored in three different colors. Now one last thing we have to do is we want to represent our ligand structure in the sphere representation. But before that, we need to select our ligand. To do this, again write the following command: select ligand, comma, we are again selecting the ligand on the basis of its name. So our selection criteria will be residue name, whose short alias is res-n, and we are providing the name of our ligand molecule, which is SAM. Hit enter. You can see in the molecular viewer window that SAM has been selected, and on the right hand side you can see yet another selection name has been created. Now we will make our ligand in a sphere representation. To do this, we will write the show command, show, but before that we need to hide the stick representation of our ligand. To do this, we will write the hide command, hide, sticks comma ligand. Hit enter. As you can see, the ligand has been vanished. Now we will show the ligand in sphere representation. We will write the command show sphere comma ligand. Hit enter. As you can see, the ligand structure has been represented in the sphere representation. We will add element wise color to our ligand structure. To do this, go to the ligand selection on the right hand side and go to the C action button. Go to the first drop down list and click on the second representation. That's it. We have reproduced this exact same image that we have seen in our paper. So this is a beautiful image of SAM3 riboswitch where SAM is represented as sphere, three domains of riboswitch with three different colors, providing an insightful image. You can apply this representation style for your riboswitch structures as well. Thank you for watching this video, and if you like that video, then please subscribe to our channel. Thanks for watching.